Okay, hello. So today I'm going to be talking about how you can create an NPR effect in both the shader nodes and the compositing nodes. I'm going to be going over how to create a diffuse and transparent material in the shader editor and how we can use passes in the compositor to generate line work by using the Sobel filter, which is already built in. We've also add in an animation for kind of wobble of the image as if it was hand-drawn every frame. And then I can add in a nice background with a gradient, and we can add noise at the very end to kind of texture the image so it looks a little bit less digital. What you're currently looking at on screen is essentially an advertisement for a node group, or a set of node groups I've already made for all of this. You can look at the link in the description. It's currently $3 on Gumroad. It just goes over basically the basics that I'm going to talk about here, and then some extra bells and whistles you can see I'm playing with in the video. Anyway, if you're not bothered with that, I'm going to get into how you can create this yourself. So before we get into actually creating any shader or compositor node tree, there's a couple of things we need to set up. So first off, you want to use EV. You want to turn down the raise and steps on your shadows as much as possible. I'm also going to make this transparent and then turn down the filter size so you get a very crisp image. And if you are using a display transform, I recommend turning it off and removing any form of contrast. You can also add the current passes that I'm adding in here. I won't be using all of them today, but in my own workflow, I use all of these passes to essentially generate line work using the Sobel filter, which I'll show you how to do in the second half of this video. Also, very important, make sure you add in an AOV in the passes there, and remember what it's called, because we'll need that in the shader editor in a moment. Also, with the lighting, we need to set up our lights to work properly with this. So if you're using a sun lamp or an area light, turn up the strength so you don't have to worry about soft shadows or how far away your lights are. And then you want to turn down the angle or the size of your light as much as possible. If you're using a point light, you can also turn the radius down to 0. I need to turn the filter all the way off to 0 and turn the resolution limit as low as possible. That way you get super harsh shadows and super crisp shadows, which we can use later. So if you want to start by creating an actual shader, I'm going to start with a diffuse shader. So I'm going to call it NPR Diffuse. And I will just zoom in a bit. I'll get rid of the principal BSDF. We don't need that. So just add in a diffuse. And we basically get the same thing back as before. So we set it to completely white, and I set a roughness of 0.5. Doesn't really matter too much. And the node that makes all of this work for EV, which isn't in cycles, is a shade to RGB. So now we can use the lighting as a color. And I'm now going to take the value, so it's just the raw brightness and darkness of our object. And I'm going to use a snap node. Essentially what this does is it will create banding in the lighting. As you can see there, as I lower it and increase it, you get more or less steps in your lighting. However, it doesn't work very intuitively. So an easy way to get around that is if you add in a divide node, and then you can do 1 over however many steps you want. So if I set the bottom number to 3 or 4, you can see I get 4 steps there. You can increase it, lower it. You can leave it as 1 and you'll just get 2 tone. But if you set it as 3, you got 3 steps. And then we can use this as a mask. So this is kind of what the drive behind all of this. So socket B is our lit portion, and socket A is our unlit portion. So if I just create a blue color and copy that over and then darken it a bit, you can see that you get the light, or the lit, the unlit, and then you get the fall off that mixes in between. So let's put all of that into a frame, just to keep it tidy. And there's just one thing which is very, very important that we do in the shader editor, and that's added an AOV node. So this basically lets us pass that mask that we just created through to the compositor. We can use that later for line work, where we can draw a line between the lit and unlit portions of our object. And make sure they have the same name in both passes on the right and in the shader editor. And next, I'm going to create a transparent or a glass material in NPR. So I'm just going to re-enable the sphere I've got here, and I'll call this NPR glass. And again, we can get rid of the principal BSDF. I'm going to follow the same kind of method that we use for diffuse, but instead of using a diffuse BSDF, we use a glossy. And you'll see where this goes in a moment. But as before, we said it's completely white, and you can choose the roughnesses to be whatever you like. I recommend a low value, and you can play around with it yourself, and you'll see it changes the size of the specular highlights. So again, if we turn it into a color using shader to RGB, and as before, we want to take the value and we can use a greater than node to use our mask, or get our mask between the specular highlights and the transparent parts of our object. So to actually get transparency here, we can add in a mix shader, and we can use that mask we've just made to drive the factor. And what we want to use here is a transparent BSDF and just a regular color. So the color here will be the color of the highlights. So I'll set that completely white for now. And something, as we can see here, if you give a transparent BSDF a color or a tint to it at all, even if you just darken it, you get very, very noisy shadows. So there's a few things we need to do to get around that. So we need to set this to blended in the material properties, which is still gives you noisy results, but it means that we can get around this in a moment. So if I set this back to completely white, we get those clean shadows with the highlights again. Let's add another mix shader node, and this time we'll take our previous result as the top shader, and we'll add in another transparent BSDF, and we'll leave this one white. This one will always be white. And what we want to do is we want to say, if there's an incoming light ray, and it's going to cast a shadow, we just want it to use a completely transparent BSDF with a white color. And that means that our original transparent BSDF, we can change the color of, we can change the tint of, and we get clean shadows. As you can see, it all still reacts to lights as you would expect. If I mess around with the area and sunlight, you can see that the specular highlights move around, and they still illuminate the monkey head underneath, as you would expect. So if I put that into a frame, transparent shadows. And there's one thing that we're going to do, I forgot to mention a second ago, is we want to turn off transparency overlap, just because it makes dealing with the line work in the compositor a little bit cleaner. So now we've created our two shaders, our two basic shaders. You can get as complicated as you like with them. We can move on to generating our line work. So I'll start with the AOV, as this is probably the most impactful one. And as I mentioned before, we're going to use a Sobel filter, which is essentially an edge detection algorithm. And you can see it already generates something very close to the line work that we want to be able to overlay onto our image at the end. And if we set our greater than to be very, very low, you get a very lenient filter. You set the value higher, which I'll do in a moment. You'll see it cuts out a lot of the noise that you can currently see on the left. However, to get the best line work possible, we can actually invert the image, set the alpha to basically only include the monkey head here, because when you invert the color, it reintroduces alpha, which we don't want. So if we just set the alpha, and then we can do the same thing as before, we can run it through a Sobel filter and a greater than node, and we get more line work, essentially. And if I flip between them, you can see why I've inverted it and done a second pass on that. Now, when we combine any of these line works as a mask, we can just use a maximum math node. So we don't have to worry about adding and then getting values over one. A maximum node will literally just take the highest value between these two. And because everything is fed in from a greater than node, it's already 0 or 1. So it's very clean. There's a little bit of trickery we can do here. So as you'll see, there's a lot of aliasing or jaggedness on the shadows. If we can anti-alias that, but then we get very, very thick line boundaries. I found that the speckle node is actually really, really good for that, where you can just stack them, and it will basically reduce the sharpness of those shadows. And as you can see, if I turn them on and off, you can see it gets rid of artifacts of the lighting from the Eevee engine. And I'm just going to increase that greater than. That's sort of like a threshold value. So now to set it a little bit higher, you see that the noise from the Sobel texture, the Sobel filter, that gets excluded, and you get a clean set of line work. So that's just one of the passes that we can use. I'm going to stack a couple more on top of this, so we get a very, very comprehensive and reliable set of line work. You can use loads of these passes. We'll do the transparent one next, but you can do position, depth. You can even use the cryptomat as well as a very reliable one. But I'll just go over the transparent one now. So as before, we can take a mask of our transparent pass. We can run the Sobel filter on it again. Run it through another greater than node. And that will force it to be a 0 or a 1. And then I'm going to take the transparency itself out of the transparent pass by separating the color and then just taking the alpha. So then we get transparency back as a black and white mask. And we can run another filter on it and a greater than, and we get another set of line work. As before, we mix them together using a maximum node. And those are our transparent outlines. I call them outlines here. It's the same thing as line work. I just flip between them when I'm working. And we can also do the same thing with the alpha pass. So I do a little bit differently here. I use a compare node. So you can set it to be, you compare it to 0.5 plus or minus 0.49. It's a more clean way to filter the alpha pass before we run the Sobel filter on it, as always. And then we can use another maximum node and add that on. And as you might see, sometimes when we add in, for example, the alpha line work, it doesn't actually contribute anything new to the image. But when you get a very, very complicated scene, something might be missed off by the transparent pass, which isn't missed off for the alpha pass, for example. Same with the AOV. So that's why we're stacking on multiple line work pass calculations. The only issue with the transparent pass as it is if I have objects behind our glass, the highlights, the line work for the highlights, if I re-render this, they're drawn on top of the objects behind it. That doesn't really make any sense. So there's a pretty easy thing we can do here. By using a subtract, we can take our line work from the AOV, and we can take away those highlights. So now you get a black spot where those highlights used to be. And then you can add in the transparent outlines on top of it. And now, as you can see, the highlights appear in front of the monkey heads in the background, which makes sense. So I'm going to do the normal pass now. This is the last line work pass that I'm going to be doing here. And I'm going to point it out specifically because it's incredibly good at finding small details in your line work. So, for example, Suzanne, the monkey head, is a really good example, because you have lots of very small kind of turns and twists. If you're doing an NPR scene, you might typically have a more simple set of objects. But because the normal pass is actually a set of vectors, if we use a separate color node, we can get the X, Y, and Z out, and then we can actually run 3 filters on each of those. So you can do it just on the normal pass directly, but you can end up running into some accuracy issues. If you split it out first, you get much better results, I find. In this case, we also want to normalize our edge detection, because it makes it easier when we take a greater than afterwards. It makes it easier to get a clean mask out of it. You can actually normalize all of the Sobel filter passes, but the normalized node can actually be quite expensive. So I try and use it only when I need to. And so if I just hook up the red, green, and blue, which in this case are X, Y, and Z, and I combine them back together, to make the thresholding here a bit easier, we can actually use a value node and just hook that into our greater than nodes. And then we just have one place to control the thresholding or how sensitive our normal pass line work is. So a higher value is more strict, a lower value is more lenient. I'll keep it as quite a low value because it's a very clean scene we have here. And it lets through a lot of that line work. Pour that into a frame. And then what we want to do is when we're adding this back in, we want to add it in before we do that correction for the transparent highlights. So in this case, I'm going to add it into our AOV line work and then leave the transparent pass to be the last thing in the chain. So you always want that subtract and maximum nodes, those two last ones, they always need to be at the end. So now if we actually want to add this line work back into our image to see how it looks, very simple. We can use, because all of this is a mask, we can just use a mixed color node and we can use the mask to drive the factor. If we plug in our original render, and then we can then use the second slot in the mixed color node to have the color of our line work. Also, something that's super simple here. If you use a dilator or road node, you can actually just on the fly change the thickness of the lines. For example, I'm rendering all of this in 4K, which means you have to get quite thin and very accurate lines. In a lower resolution, if you're rendering at 2K, for example, probably don't need to use the dilator road, but it is very handy to have it nonetheless. So all of that in a frame, and that is our line work. Again, you can always stack more and more things and more passes onto this. So now we've got our line work. We want to try and make this look a little bit more interesting. And I'm going to add in something that can make an animation look a lot more convincing. Especially if you're trying to do like a cartoon kind of effect. We want to just displace our image a little bit so it looks like each frame is hand-drawn. Obviously it's not, but if we add in a bit of noise into how the image is displayed, it can look like the inaccuracy you would have if you were drawing every single frame by hand. Every frame is going to be a little bit different. So I'm going to add noise texture here, set it to 4D. I want to set the W value to be the only driver that I know, which is hash frame, and that actually just gives you the value of the frame. So as you scrub through, your noise texture will change. And I'm just doing a bit of normalization here because the noise texture is a bit of a pain to use directly as a displacement. So we want to take half off, put it into a scale node, and then we can affect, using the scale node, we can control how strong the effect is. So I'll probably actually keep the detail for this a little bit higher than you might think. Turn the roughness down a bit. So you can kind of get an organic kind of pattern, and then reduce the scale. And now if you see as I scrub through the frames with my arrow keys, you can see it moves a little bit. And it's much more convincing when you have a low frame rate animation. So 12 FPS I find works really, really well for this kind of thing. So next, let's add in a background. So just very simply using an alpha over node, we can choose any color we like. And if you're happy with just a solid color, you can skip to the next bit. But I think for the kind of style that I'm going for, a gradient background is really, really nice, especially if you have a sky, for example. Having just a slight gradient makes it look a lot more interesting. So there's an easy way we can do this. There's already a gradient texture in the compositor. We just need to rotate it. So I want it to go from top to bottom. If we use the normalized coordinates and plug that in, we can see it goes from left to right. I want to rotate that. So if you add a vector rotate, you change the center to be the right-hand side of the image, and then rotate it by 90 degrees, you get it top to bottom. And now you can essentially use that 0 to 1 mask from the gradient texture I'm going to have it change the hue of our background color. So I'm going to add in a hue saturation value node. I'm going to add in a standalone color node. I'm going to copy that background color over and plug that in. And then I'm going to use the gradient texture to drive the hue of our background color. So in this case, it's way too strong because it immediately creates a rainbow. I want to be able to control that strength. So if you use a math multiply on the gradient texture, you can reduce the value and you get a nice, much more subtle fall off with the hue from top to the bottom. So put that in another frame. And next, I want to soften the image a little bit. So it's currently very digital. It's very obvious that it's all perfect. So it's super easy way to do this is just stack anti-aliasing nodes on top of each other. That already softens it and gets rid of the jagged edges. And then I run a soften filter over the top as well. And that will work really nicely with when we want to add a bit of noise into our image. So if you were trying to recreate this being drawn on paper, it's pretty clear to tell that this isn't paper. So what I do, and this is just my preference, is I add in white noise. I also add in a GABA texture afterwards. But here I'm adding in a white noise texture, and I'm going to overlay that onto the image. Same as before, if I want to animate it, I can just put hash frame into the W value and plug the value in. And immediately it looks much more interesting. I'm leaving these values quite high, so it shows up in the video quite well, but you can play around with the factor as much as you like. So here is the GABA texture. I'm always looking for an excuse to use this node because it's really interesting, but I find it just kind of fails when compared to the regular noise texture. It also doesn't have a 4D mode, so there is no easy way to animate it. We can actually get around that very easily in the compositor by warping the image coordinates. So image coordinates basically tell us how a texture is placed onto the image in the compositor. And if we just plug in the uniform coordinates, nothing actually changes. But now we can manipulate how those coordinates are placed. So if I put the hash frame driver into that vector math add, it actually just shifts the GABA texture over on every frame. So it creates the effect of animation. So that is everything I've got. Hope it's helpful. Again, link in the description for my own add-on. But yeah, any questions in the comments?